Wisconsin depends heavily on groundwater. People use it for drinking and bathing, for industrial processes, and for growing crops. Figuring out how much of this precious resource we have is the job of hydrogeologists like Andrew Leaf. Leaf is working just outside Madison, Wisconsin, where suburbs are rapidly expanding. That's putting heavy demands on the groundwater used by homeowners.
The interest here is to try and figure out where the water in these springs are coming from.
The springs are cold, but Leaf is putting hot water down a well to figure out how water is flowing underground. The project is supported by the University of Wisconsin Water Resources Institute.
One of the big challenges in hydrogeology is the geology, actually. So how the different rocks conduct water. It can move much faster in some layers than other layers, and that just depends on how the rocks were deposited. What's challenging about that is this is all happening underground and we can't see it. Temperature is one way to measure the movement of water because the water carries heat with it as it moves. We can lower one of these cables down a well and we can leave it in the well, stationary, and we can snap whole profiles of temperature in the well every minute, pretty much, is what we're doing here.
Dr. Gene Barr is Leaf's thesis advisor at the University of Wisconsin-Madison.
What we're trying to do here with this temperature sensing is get some additional information on the variations in permeability within those bedrock units. And the idea is that water that's flowing more readily through the system will dilute the temperature pulse that we're going to introduce into the well more rapidly. So that'll give us some additional information on flow zones and also on the vertical flow within the well here. But what we're going to do today is we're actually going to create an artificial perturbation of that temperature profile and then watch it decay as we turn that off.
So this is our intake for the heating system. It's just a Groundwater environmental sampling pump.
Hot water is flowing out into the formation preferentially at certain zones as well. So. But it saves
this special box called the distributed temperature sensor pulses a laser light down the cable. And inside the cable and the quartz, inside the fibers, there are reflective properties that change with temperature. And so there's a reflected signal that comes back to the box. It can measure that, and it can calculate temperature along the entire length of the cable.
Dr. David Hard is another researcher on the project.
That's going to pump the water up the clear tube here, through that coil, through the flow meter, down into the heat exchanger where it'll get warmed up. The water will get warmed up. It will come out, go through the black garden hose all the way down to the bottom of the well, and then it will just keep pumping and circulating. So the pump's at the top, it's sucking the water in, and then the black hose is at the bottom pushing the water out.
There is a very conductive, there's a zone in the Wanawak that's like 100. We're hoping that by observing the changes in temperature, we can see not only areas where groundwater is coming and going from the well, but we can also see flow of water in the well itself.
The experiment has been promising.
We think this is kind of in addition, and it complements some other geophysical logging tools that can be used. And so this project is really sort of a proof of concept of this as a methodology that might be used more widely for looking at bedrock aquifers throughout the upper Midwest.
This work is brought to you by the University of Wisconsin Water Resources Institute.